Hello everyone. I guess since still we are waiting for some more people to join in till 14. How was your weekend? I can understand that VIT has you served your Saturday and that you're looking for something good for your Sunday. So how is it going? You can freely unmute and speak till we start the event.
Oh, you can use the chat box to reply as well if you're unable to unmute. I guess everyone is so tired that they're unable to reply. All right, Aditya says it's going good. Great to know, Aditya.
Oh, Soumyadeep seems to have had a boring weekend. It seems it's no problem. That's the reason why you're here, so that you can light up your um, rest of leftover weekend. Say, just hang in there for a while. So we're gonna take you through something that's very interesting that we hope that you'll enjoy. Okay then. So it's already 4:10. So let's get started with our weekend. So wish you all a very good evening once again. And after losing a beautiful Saturday to VIT's unanticipated schedules, we can understand that you might be looking out for something that can light up your Sunday. Well, that's exactly why we at Team Samarth are here, bringing you ROC1001 Fundamentals of Rocketry. Throughout this event, you will see how true engineering looks like, how rockets are built from scratch, and what is it that goes into it, all while showing what we at Team Samarth actually do to build such rockets and other stuff. So, without further ado, let's get started. So, what is Team Summer, you may ask? So, we are a bunch of aerospace enthusiasts who appear for international competitions held annually by very eminent organizations. It is for these competitions that we build rockets and other interesting stuff. These competitions are actually difficult, I must say, given that there are many teams appearing from all over the world, which have very good experience and have cutting edge technologies that can support their work. So before we actually delve into learning the fundamentals of rocketry, we shall show you a glimpse of what these competitions are in a nutshell, so that you can understand what is the premise of our work. So let's get started. So the competition for which we build the sounding rockets is the Spaceport America Cup. So if you think of joining Summer at some point, you might imagine standing amidst such a crowd holding one of your own indigenous rockets. So that's how exciting it is. So this competition is held by an organization called ESRA, that stands for Experimental Sounding Rocket Association, which is held at Spaceport America in New Mexico. Well, the name Spaceport America might ring some bells for some of you. So, this is the place where Virgin Galactic took off for its first space flight that took place recently, a few months ago. So, for this competition, we build sounding rockets. Sounding rockets, and the sounding in sounding rockets means measuring in scientific terms. Though, let's not go into the literal meaning. Coming back, so for this competition, we build sounding rockets that are expected to reach an altitude of 10,000 feet and carry an experimental payload inside them. So, the experimental payload, as the name suggests, um, they are expected to leverage the physical conditions that our rockets provide in terms of, say, gravitational force, altitude, etc., to name a few, for performing some very interesting experiments. So, what actually goes into making such beautiful pieces of engineering is what my friends will be explaining shortly. So, this was Spaceport America Cup. Apart from this, we appear for another competition, which is also our flagship. This is the CanSat competition. So, you might not believe, but this is conducted by a conglomerate of much coveted institutions like NASA Goddard, American Astronautical Society, Lockheed Martin, and Siemens, to name a few. So it has very, very big names associated with it. So for this competition, we build a CANSAT, which stands for Canister Satellite. What happens in this competition is that this CANSAT would be taken to an altitude of 700 to 725 meters by a rocket and would be deployed at the peak altitude. Upon deployment, this CANSAT is expected to perform some really, really complicated things like deploying payloads in a specified manner, or maneuver while it is coming down in a certain way. This might sound, it is not as easy as it sounds. So building of CANSAT needs to be done under very, very stringent conditions in terms of, say, the limitations put on the total weight the CANSAT has, or the limited power supply that you have, or other structural specifications. So the picture of the CANSAT that you see here is what we at Team Summer built for the 2019 version of the CANSAT, where this CANSAT was expected to descend after getting released from a rocket while it spirals in a controlled manner. It also needs to keep communicating with a ground station that is set up in a tent at the ground while making sure that the communication is uninterrupted. So, Team Samarth was, to give you a few more facts, Team Samarth was actually founded in 2017 to appear for CANSAT competition before it actually forayed into the SA Cup competition that we discussed before this. So, till now, Team Samarth has appeared for three editions of CANSAT in 2018, 2019, and 2021, where it bagged 18th, 20th, and 13th positions worldwide, respectively. So that is something that we proudly boast of at Team Summer, and we are looking for achieving more laurels in the times to come. Now that you know what we at Team Summer indulge in, it's time we take a look into how all of us Samardians build this stuff piece by piece and come together to reach the skies. So let's get started with the mechanical domain first. What the mechanical engineers basically do is, I can put it this way, it is like mechanical engineers give flesh to the rocket, as I would like to call it. So my friend Sankalp will take you through the working of the mechanical department. Over to you, Sankalp.
Thank you, Pradyumna. Good evening, everybody. So, rockets are the pinnacle of engineering. They comprise of all the theories, laws, and principles that you will ever learn and see. So, let us see what goes into the rocket's physical construction. Now, there are several things we need to design, test, and manufacture in a rocket. These include structures, aerodynamics, propulsion, and recovery. So, these are the major building blocks of a rocket, and everything, I repeat, everything is interrelated. So let's take a deep dive into what all these things represent. Let me talk about the structures department. So this is the hardware of a rocket. Let me tell you how drawings and computer models are turned into physical parts with an example of our nose cone. So the first step is design. The aerodynamics team will send us the curve profile after thoroughly analyzing the aerodynamics of the nose cone. Then we will take this curve profile and create a CAD model or a computer aided design, which is going to be a solid model made in software like SolidWorks, Fusion 360, ANSYS, or so on and so forth. So after this, we will select the manufacturing process and materials to be used on the basis of strength required, strength required, availability, and ease of fabrication. At the end, we manufacture and assemble the final rocket, and this is how the structures department works at Team Summer. Let me pass it on to the aerodynamics department now. Over to you, Anubhav.
Hey everyone, I'm going to talk to you about aerodynamics or the study of air in motion. It is something that we use to make sure that our rockets go exactly where we want it to. So, why do we need aerodynamics? It's pretty easy to see the effect of aerodynamics in any rocket. On the left is a sounding rocket which is designed to go, say, a few hundred meters up to the stratosphere, while on the right is an orbital rocket designed to throw satellites into orbit hundreds of kilometers above the Earth's surface. You can clearly see the difference between them. One has a pointy nose to cut through the atmosphere, while the other uses a blunt nose to prevent heating. One has wings for stability while the other lacks them to reduce drag. Our rocket that we built have more in common with the sounding rockets, and that is due to the same laws of aerodynamics which governs all our designs. Well, our knowledge of aerodynamics is only half of the problem. We must know how to apply it. This is where computational fluid dynamics comes in. Computational means that a computer is responsible for fluid dynamics. We use it to simulate the fluids and find out exactly what the effect of air is on our aerostructures. We use this to find which of our designs is good and which are not. Well, we can design a rocket as good as it can be, but it's going nowhere without a rocket engine. This is where the propulsion department comes in. There are really three types of rocket engines: a solid one, a liquid, or a mixture of the two. Solid engines are what you'll most commonly find in sounding rockets because they're easy to use and are pretty cheap. Solid rockets have a solid powdered fuel, a oxidizer to ignite the fuel, and a plastic to keep everything together. The oxidizer helps ignite the fuel once it is heated and releases hot gases, which are channeled through a nozzle to provide thrust for the rocket. Now over to Ankit, who will tell you about how to recover the rocket.
Well, thanks, Anubhav. Recovery system is the backbone of mechanical department. With your humongous curiosity, you might be thinking, what do we do in recovery department? I'll provide you vivid and a brief illustration about recovery department one by one. This is dual parachute deployment system. As the name suggests, two parachutes are ejected out of rocket. First, drop parachute is ejected at apogee. As you guys can see in diagram also, as the rocket descent, a secondary ejection charge is fired, and due to it, main parachute is ejected, which will lower the descent rate, which means it will slow down the speed, and it won't damage upon hitting the ground. Now, CO2 ejection charge mechanism, as it is displayed in this slide, and the parts associated with it. Here, we use little amount of black powder to push CO2 canister towards the pin, as it leads to ejection of CO2. This will ultimately create pressure difference and thereby enabling ejection and opening of main and parachute, main and drop parachute as well. Black powder uses 4F black powder as charge to create a controlled explosion. This will create ultimately the pressure difference, thereby enabling ejection and opening of main and drop parachute. So thank you everyone. And with this, I would like to adjourn. Over to you, Pradyum.
So thank you very much. So guys, that was the mechanical department for you. Now we shall take a sneak peek into the department I belong to, that is the electronics department. If mechanical department builds the flesh, it's the electronics department which forms the heart and soul of the whole rocket. So my friend Chandrashish will walk you through this domain. Over to you, Chandrashish.
Yeah, hi, thank you, Pradyumna. Good evening, everyone. So, the electronics, you might be wondering that why do we require electronics in a rocket when it's just a tube that has to go up into space? And you know that when we are talking about Elon Musk and the rocket he builds, there are all sorts of computers that are being put into use that come under the electronics domain itself. A rocket is not only about shooting a tube up into sky, it's about analyzing the data that we can receive from it. And the analyzing of the data is done by the electronics department. So a brief overview of what the electronic department does throughout every team or organization that builds rocket is they select the hardware components that go into the rocket. They design the printed circuit boards that on which the hardware components, the sensors, the microcontrollers are mounted. They design the communication system that allows the rocket to communicate with the ground station and tell and discuss all the sensor values as well as the readings, various readings we get from the sensors, as well as deciding the software for the flight, deciding the algorithm for the flight software. Now, when we talk about the flight software, it's basically determining that where the parachute will eject and where the rocket motor, when the rocket motor will ignite, and all the different tasks that a rocket or a canister satellite has to perform throughout its throughout its flight. One of the most important thing that the electronic departments has to do is to simulate circuits. Now, simulating circuits is a very important part for our team as well as all the different organizations that build rockets and stuff like that, because the hardware that we use and the components that we use are not cheap, and leaving it solely on luck that what we buy should come in handy for us is not at all a practical approach. So we need to ensure that whatever we are choosing will work for our use. Only then can we go ahead and purchase it. Whether it's a multi-billion-dollar organization like NASA or a student-run team like Team Samar, this is one of the most crucial parts of the electronics department. So now that you are well versed with what the electronics department is supposed to do, let us go a bit deeper into how electronics department at Team Samar and any other student team might work. So heading over to the hardware, which will be taken over by Anirudh. Over to you, Anirudh.
Okay, yeah, thanks. Hi, everyone. So, I'll be taking you through my experience of hardware circuit design that I had here in Team Summer. So, as we work on the CANSAT and Rocket, we are definitely going to need a lot of sensors to acquire the required data for sampling, and for flight analysis and all the stuff, and also to meet all the requirements of the problem statement. So, for this purpose, we also need a microcontroller which is placed. Now, while working on these projects, we work with a wide range of microcontrollers. I've placed a few of these, as you can see, like the Arduino board or the advanced STM Nucleo board or the Raspberry Pi board, or working with the sensors like MPU for orientation and VMP for the pressure and all the temperature data. So these, we collect the data and, for the post-flight analysis, we require them. Now, after prototyping these circuits on a breadboard, it's now time to integrate them with the structure. For that purpose, we use printed circuit board to connect all the devices and place them on the structure. Here we got a before and after kind of image. Like on the left, you can see the board design, which is from a screenshot from the EagleCAD, the tool which we use to design the PCBs. And on the right is the finished product after manufacturing, ready to use. It requires a great deal of skill for strategically placing all the components on the right place. And it's also kind of a cool job. So now also we need to transmit all our data in real time to the ground station for plotting and analysis. So for that purpose, we use an RF module in our CANSAT called the XD, which works on the Zigbee communication protocol. With this module, we also get to select the suitable antenna, not just for the module, but also for the ground station to receive the telemetry. This part is quite important as there's almost nothing we can do without the data we receive in the real time during the flight. Now, one of the greatest projects that we took up this year is our flight computer. So let me give a brief about what a flight computer is. So it basically acts as a data logger on the rocket, like sampling and storing data for the post-flight analysis and simulations. Not only this, deploying parachutes, and if the rocket has air brakes, then controlling those, and if we have a deployable payload, then working on that too. So basically, it's the brains of a rocket. Now, actually, we need to include a COTS flight computer, that's the commercially available one, as a primary data logger for the competition to keep it fair. But we are in the process of developing our own flight computer, which will be used as a secondary device. So in case the primary fails, then we'll have a secondary in use. We have laid the founding stones this year for this great project with endless possibilities. As for our microcontroller on board, we have chosen an ARM Cortex M3 category controller, the STM32. This one has great potentials and it fulfills all our requirements. It's also much easier to scale up in the future. So initially developing it as a data logger, we have much room for improvement in the coming future. We are planning to test out our flight computer in an actual launch this year for the SA Cup and make it ready for the secondary use. So that was it from my side in the hardware part. Now my colleague Chandrashish will take you through the software development and simulations. Chandrashish, you're on mute.
Yeah, so thank you, Anirudh, for explaining to everyone how the hardware side of electronics works. Now coming to software, which I believe integrates everything in the rocket together. So you might be thinking that software is the work of the CS department, right? So why are we talking about it in the electronics department? The thing is that you might be used to working with things that are plug and play. The mouse you use, the mobile you charge, and everything around you right now is plug and play, right? But when it comes to the work of developing projects and developing circuits as well as creating your own things, it's not as easy as plug and play. You will have a sensor hardware, you will have a microcontroller, but you cannot just connect the power pins and expect everything to work. In order to integrate it all together and in order to make sure that you are getting what you want out of your hardware, you use a lot of software. Now we use software for mainly three purposes. The first is designing the printed circuit board, which Anirudh already mentioned. The second is the simulation part of it. Now, you guys are all, there are a lot of first years present with us over here, and you guys have been using software since college is going online for your labs. You know how simulation softwares with regard to electronics work, that you have to say simulate a power amplifier or a common emitter MOSFET or stuff like that. Over here, the softwares we use are a bit more complex because our circuits are not that simple. We are not only using a few resistors and capacitors in series and parallel and trying to find the voltage. What we're actually doing is we're trying to simulate that whether the microcontroller, the sensors, and the different modules will be working together in peace, in harmony or not. In order to do that, we use a software called Proteus, where we can simulate entire Arduinos and Raspberry Pis, for those of you who know it. And it's just like a video game where you can think of all the hardware components that you're going to use, code them in the software, and see them run on your laptop screen. So that is the use of Proteus, which is just a software used by Samar for microcontroller model and simulations. Moving forward, we also use a SPICE software, or not one, but two SPICE software. So first I'll explain to you, for those of you who don't know what a SPICE software is. A SPICE software is basically the kind of simulation software all of you might have been expecting. When we want to simulate the voltages at different nodes of a circuit, when we want to simulate the current that is passing through a particular component, or the simple circuits that you say, but with a lot more complex components, we use a SPICE software. If we go according to what Google says, SPICE is a computer simulation and modeling program used by engineers to mathematically predict the behavior of electronic circuits. Just what I said, put into better words somehow. So we use two types of SPICE software. That is, one is LT-SPICE, and moving forward, you'll see we also use multi-sim, which I feel a lot of you would be accustomed with. Now, you guys might be wondering that why are we using the same kind of software for the same thing, but we're using two different softwares. So the sad truth in the electronics department is that there is no one software for everything in the life of an electronics engineer. The thing is that these softwares, the components that we use, they have their own libraries, which are available online, and we can download them for a software and use them. Now, the thing is that some components are available on multisim, and some components are available on LT-SPICE, and some might be available on a third piece of software. So we keep our options wide so that we can experiment with a lot of different components and are accustomed with two different simulation softwares, with the flexibility to move on to a third if required. Now coming to the third type of software, which a lot of you might be knowing about if you have been working with Arduino, that is the programming software. As I mentioned earlier, nothing is plug and play in the world of, in our world where we are developing stuff. So we have to ensure that the microcontroller is communicating, and then with the sensors, and then there come in a lot of complex terms such as clock speed and I2C and SPI, which is a little pain in the back. So in order to communicate, in order to type what we want the controller to do into the controller, we use an IDE. Now the thing is that we, being a student-run team and a team which is building rockets, Arduino is not the solution for every problem. We have to move on to more powerful microcontrollers such as Raspberry Pi and STM-based microcontrollers, TNC-LC, to name a few. Everything cannot be programmed on Arduino IDE. So we need to have we have different IDs for different microcontrollers. The most common one is Arduino IDE, which has its own limitations. So that is why we also use STM32 Cube IDE, which is specifically used to program STM, which Anirudh even mentioned earlier. In layman's terms, it is just like the elder or the eldest brother of Arduino, who has got the big muscles and the processing power to churn through numbers really quick. So yes, Samar uses multiple IDs to develop software for different microcontrollers, and that also comes under the electronics department. That is, we guys are the ones who will be coding the microcontrollers to get the work done out of them. Now, heading back to our senior Pradyumna.
Thank you, Chandrashesha and Anirudh. That was a wonderful explanation of what we do as the electronics department. So, guys, that was the electronics domain for all of you. Now, let's move on to the computer science department. You might be wondering what's the job of a CS engineer in building a rocket. Well, to put it in a nutshell, they form the nerve center, or they form the technical support system that takes care of the whole mission. What I actually mean by that is what my friend Jatin will tell you in an elaborate manner. So over to you, Jatin.
Thank you, Pradyumna. So, hello guys, this is Jatin, and now we'll be moving on to the CS department. So, as Pradyumna rightly said, you must be wondering what the CS engineers do in a rocketry team. Well, basically, the CS department is divided into developing the ground control system software and the website. So, the ground control system software acts as the central nerve center for the entire space system. You guys must be wondering what exactly that is. Well, it is a combination of hardware and software that is developed or built for keeping track of what happens during the flight. The CS department develops software that the team uses to keep track of the data received from the onboard flight computer and to portray the data to the users. I know it may seem a little complicated. I used to think so too a year ago. So let me break it down for you. So for the GCS, we work on a GUI, which is a graphical user interface, which is mainly used for receiving and handling real-time telemetry. It is also used for processing, analyzing, and displaying data. And we also work on 3D models and real-time tracking of the rocket. Now, the skill set needed to work on a GCS is good programming skills, good problem-solving skills, and a lot of coffee. The programming language that we are currently using is Python, but there is no constraint in that area. The main process of the CS department is to research, learn, implement, and repeat. A lot of the times we come across new concepts which we need to work around to progress in the project. And as we all know, our job as CS engineers would not exist without Google and Stack Overflow. This is why first we need to research the concepts, learn them, implement them in a project, and then repeat. The CS department also has a couple of very cool ideas that we are working on at the moment, which you will find out if and when you join the team. Now we'll be moving on to the website part that will be handled by Sia.
Okay, hello everyone. My name is Sia and I'll be taking you through the website. So, a great web design is more than just pretty pictures. So, living in the digital world, a website is crucial for any business. And as you were told, that Team Samad, it has been participating in 2 annual international competitions. So, it needs to stand out in every aspect, and the website being one of them. So you might be thinking that why do we need a website in a rocketry team? So the reason is that it provides a map and directions to the team's working flow, competitions, events, achievements, etc. for sponsors to locate us easily. And it not only gives credibility, but it also helps to give a positive impression towards the sponsors that our team is bigger and more successful, and hence giving them a proper reason to sponsor us. And here's the fact that building a rocket and a CANSAT in a year takes some serious amounts of money. So now you know how important a website is for us and why we need it. So coming to the technicalities, our website uses tech stack and it has been designed using a library of JavaScript that is React.js. It even deals with the views and lets us choose the front-end architecture and allows us to build a complete framework around it by adding a few libraries like 3JS that we use for 3D models. AOS and React Reveal for beautiful animations, and much more. And it even helps to create reusable components, which makes our work a lot easier, and that's a reason we prefer React.js over any other framework. So now we're basically looking for people who can work on constantly upgrading the website with all the required changes like freshening up the content, adding images and videos of the events that we are conducting, and improving the page speed and making it better and better in any way they can. So we even need to integrate backend features that make it more user friendly and such that people are able to reach us in the simplest way possible. So altogether, it's about how much creativity you can put into your website in such a way that it looks top notch each and every time it's accessed, as most of our sponsorships and collaborations depend on that. Okay, so that was it from my side. Over to you, Pradina.
Thank you, Sia. Thank you, Sia and Jatin, for showing us what we do at Team Summer for the computer science engineers. And I must say, for a computer science engineer, it seems as if getting into a top-notch IT company might be the end goal for most of them. But I must say, this is an equally interesting job because there is a lot of things that you get to learn while you develop what Sia and Jatin told you about, especially the GUI and the website, because they are constantly scaling up, and it requires you to know better things than many of the CS engineers out there. So it's something that is very, interesting that someone would find to work on. So that was the computer science domain for you. Now, having seen all the engineering that goes into our work, you might ask what more is left. As they say, behind every successful man there is a woman. There's always a vital support system that manages to keep everything smooth and progressive in a large organization. And for a team like us, that support system is the management domain. You cannot actually imagine a smoothly functioning team without a proper manager. And yes, they are required to be as skillful, meticulous, and creative at times as you would expect any other talented engineer to be in EIT. So my friend Dhananjay would now tell you what is it that goes into managing a wonderful team like Team Samarth. Over to you, Dhananjay.
Yeah. Hi, I'm Dhananjay and I'm part of the management team here at Team Summer. A year ago, whenever I saw a beautiful poster on Instagram or any other social media platform, I used to wonder how people came up with such unique ideas. Well, Team Summer gave me an opportunity to explore the designer in me. We at the management department design and handle all the contents in our official social media handles. So if you want to get a gist of our work, don't forget to check out our Instagram page. We use various softwares like Canva, Photoshop, and Figma to make them. Well, designing is just the start of the show. We also handle next slide, please. Yeah, we also handle the finance of the team, starting from attracting sponsors to keeping track of all the purchases made. Handling the logistics of the team is also our responsibility. We plan all the domestic and international travels of the team. Overall, it is the management department that keeps the team organized and in good spirits. So if you're an all-rounder, then don't think twice before you fill the recruitment form. Now over to you, Pradyumna.
Kind of adding to what Dhananjay said, it's the management team that also keeps the team sane at all times, because there are n number of things that can happen while you work in a team or any other organization for that matter. So it's the job of the management team to be like your mother at home, to keep you require that management team to keep the whole team sane and to keep things progressive. So thank you, Dhananjay, for explaining what the management team does in Samarth. Well, now we finally have reached the end of the presentation. So that was the world of Rocketry as we see it, and the world of Team Samarth for you guys. If all of this has sparked some interest in you to know more about what we do at Samarth, do check out our social media handles, as we are available on Instagram and Facebook. And Team Samarth also has its own homegrown website, as Sia was talking. So I'd highly recommend that you guys go and check it out on teamsamarth.com. You can use these handles to reach to us. So we hope you enjoyed the session and that you see yourself as proud engineers doing some real engineering throughout your BTech, just like the way we do at Team Samarth. So thank you for patiently listening to us. Now, I shall open the floor for some discussion. So now you may freely ask any doubt if you have. Thank you. Thank you once again. You can unmute yourself or you can put your questions in the chat box so that we can answer you. Shoot your questions.
Hi, I'm Somadeep.
Yeah, hello Soumyadeep.
Yeah.
Hi,
So
Sophie.
my question was, do you outsource your rocket engines or do you build it in-house?
So currently we are having we do both. It depends on the competition requirements. So we can either outsource this or and we're also in the process of building our own hybrid rocket engine right now.
Okay. And what is the highest altitude level your rocket has reached till now?
So we'll be
Like,
launching the first time this June, and we'll be
okay.
reaching an altitude of 11,000 feet, 10 to
Okay.
11,000 feet.
Okay. Thank you.
Any other question, guys?
So if I want to apply for the software development team, I'll possibly also be working on the Arduino team, right?
Yeah, so here, like what you saw was a very brief overview of how the departments work, right? Every department gave you a concise uh, boundary of where they work. But when you're working as a part of a student team, nothing is black and white, right? There is a lot of interdepartment work, and a lot of times the departments collaborate with each other and help each other out, not on a very formal note, but very informal.
Mm.
So to cut it short, yes, when you be a part of any one department, you will be able to give in your inputs and work for other departments as well.
Okay, thank you, man.
Yeah.
And what is the height of the rocket you have built that will go 11,000 feet?
The height of the rocket is around 10 to 11 feet.
So it's going like
Almost.
1,000 times its height.
Yeah.
That's a lot, man.
And you'll be interested to know that the maximum velocity it can achieve is around 1,000 kilometers per hour, and that is just in 4 seconds.
Yeah, that's really cool. Thanks.
So when are the recruitment starting for the team?
Right. So right now we're still waiting for instructions from the DSW, but in the meeting chat we have given the link for a WhatsApp group as well as all the official handles of Team Summit as well. So you are requested to join the WhatsApp group where periodically the updates will be given, as well as follow us on Instagram where the official recruitment poster will be released first. But as an estimate, you can assume sometime in March.
Okay, thank you.
The rocket that you're planning to launch, is it actively controlled or passively controlled?
It's passively controlled using fins.
Okay, great.
Guys, you talked about rockets right now. Aren't you having any other questions, curiosity about the team, how we function, where do we source the components from, what is the procedure for selecting the components? Go on, shoot your questions. You can ask anything you want. You have doubts regarding how a team functions.
So I heard you guys do experimental payloads for the rockets in electronics department. So what kind of payloads do you make? Like what kind of ideas?
All right. So the experimental payload is a thing that we get complete freedom as the electronics department to think whatever research-based idea we want to put. So we cannot exactly tell you that what is being done this year. You would have to be a part of the team for that. But some of the payloads that we have done in the past is where once we, uh, mm, uh, tested the gyroscopic effects of a rocket motor, like how will it perform in space. So that is something that we do, and electronically, you will have complete freedom to check or to put whatever payload you want. You can for example, you can put in something and check the effect of cosmic radiations or at that altitude, or you can have complete freedom for research, whatever you want to research for.
Adding to actually what Chandrash said, and don't have the impression that it's only the electronics department which is actually involved in the development of the payload. The payload can actually perform anything under the sun that you can think about. So if you were actually to find out what other teams do in such competitions, they come up with very very innovative ideas that range from say cellular biology to something that relates to fluid dynamics, or something again that relates to say wireless power harvesting. Wireless power harvesting is something that is very interesting. It's kind of something, it's something that you can think of that happens in experimental payloads. So through the experimental payloads, we try to explore and delve into newer and newer technologies that are emerging today. So yeah, so that I just wanted to add that point. I think someone has asked what
But
will be the general structure of the recruitment procedure. I guess Chandrashish, you had to add something.
yeah, so the general procedure of the recruitment will be that we'll be asking you guys to first fill out a form whenever the dates come out, and after that we'll be holding interviews, and we'll be talking to you guys, getting a good idea about what your interests are, and according to that, you guys will be recruited for the team.
What exactly are you looking for in a candidate this year?
Uh, what we look for in a candidate is, first of all, not at all year specific. We want people who are enthusiastic and hardworking, as simple as it is. We want people who can devote their time for the team and work hard on a daily basis, and who are interested in making stuff and designing stuff and have the curiosity to learn.
Yeah.
What if we lack a bit of technical knowledge in the domain that we are applying? Like
Correct.
not a big gap, like a small gap.
So none of us joined as masters of everything, of anything. Neither are we still masters of everything we do. We are also on the process of learning, and we also joined the team as people who had some idea about stuff, but were not experts at anything. So of course, if someone has the willingness to learn stuff, they can make their way through.
Okay, I think someone has asked what are the kinds of motors that we deal with. I think Sankalp or Anubhav, you wanna answer that?
Yeah, this year we are using a solid rocket motor, which we've commercially obtained, but we are looking into researching hybrid motors, which use both solid and liquid fuels.
One of the most interesting things I find about our team is that right now the world is riding on the wave of space tourism. And everyone is fascinated by Elon Musk and the rockets he's building, SpaceX and Virginia Tech and Virgin Galactic and whatnot. So when we are a part of a rocketry team, we actually understand the terms that they are using, what they mean by active controls and passive controls and fins and nose cone and this all the stuff they're talking about, telemetry and data rate. So we feel that we are a part of that wave, and we are contributing to it somehow by developing younger minds and pushing them in that direction so that they can build their careers in that domain as well. All right, there is another question in the chat. I think Sankalp or Anubhav or someone will be able to answer.
I think you just unmute and explain your question. Aditya?
No, fine if he doesn't want to. So there are many different ways to deal with heat. Mainly for these smaller rockets, what we oh yeah, no problem. For mostly these solid smaller rockets, what we prefer is that we use an ablative material. So the heat use a material with a high heat capacity, so it carries the heat along with it while the engine is firing. So it keeps the rest of the motor cool while eating through a layer which we want, which we can sacrifice, essentially.
I wanted to ask that have you ever built a reusable rocket yet?
Yeah, so actually the rockets we build are reusable. They're not landing rockets, but they're reusable in nature. Like the whole body tubes and everything are reusable. You can just add a different new motor and it's ready to go.
Okay, that's cool.
Yeah.
So the main difference between the performance of solid and hybrid motors is motors are normally way more powerful, but hybrid rockets are more efficient. So there's a trade-off between high power, low efficiency, and little lower power but much higher efficiency. Uh, so that how we select an ideal one is what basically our team does. We shortlist many different rocket designs, and we test them using simulation softwares to see which one's ideal for what we want to do, like go to 11,000 feet. Yeah, again, from temperature is one of the things that is one of the data that we obtain from simulation. But because we are using sounding rockets, the temperatures aren't that high that they actually affect anything. So I don't think temperature data is that useful for sounding rockets, at least.
All right. So regarding international competitions, I think Pradyumna will be able to answer better uh, about the
Yeah.
performance.
So Aditya, as I've told you earlier, we have appeared for the 3 years of CanSat in 2018, 19, and 21. In 2018, we bagged the 18th position worldwide and first in the Asia Pacific region. We were first in Asia Pacific and 18th worldwide. In 2019, we were placed 20th worldwide, and in 2021, the last year, we were placed 13th worldwide. So it's a kind of upward graph. So we with a larger team now, and we expect more talented people to bring us more laurels to the team. So that was with respect to CanSat. And in the Spaceport America Cup, I guess Sankalp, you would be able to elaborate.
Yeah, so in the Spaceport America Cup, we participated in the virtual edition, which was last year because that was during the pandemic. So in that we came like 23rd worldwide, and we had in our category, and yes, we built the rocket. Even though it was the pandemic, we manufactured the entire rocket. We came and we just tried to build something out of it. It's not launched yet, but yes, we're hoping to launch it very soon. Yeah. Cost of building a rocket.
That's an interesting question. That's an actually interesting question. Want to answer that? Someone wants to answer that?
Okay, so basically, yeah, it's quite expensive. It's quite an expensive affair, I would say. I don't know. I mean, the actual entire cost, I won't reveal that right now, but yeah, it's pretty expensive. Like each component, for example, the nose cone which I demonstrated, the example I gave, that itself can cost you around 1 lakh. So it's pretty expensive stuff, and it's because obviously the reason is the material and the manufacturing is pretty expensive. Though that takes most of the cost. The labor required and these technical skills required is really rich in this aspect.
It goes around like 6-digit, 7-digit figures. It goes till that's all we can disclose at this point. So, because these are actually very sophisticated things, and quite a few materials, except for the mechanical, because the structural components can be manufactured here by sending it to some manufacturer. But a few electronic components, not a few, even a lot of electronic components that are required for the competition are not available in India, because a lot of manufacturers are somewhere in, say, the US or other places. Except India. So we many times we'll have to import them. So a lot of cost goes into that also. So these are the kind of things that make the whole mission very costly. Yeah, that's that.
Right. Farhan asks, what are the difficulties when building a hybrid engine?
Compared to solid engines that we have more experience in, hybrid engines use liquid as half of the propellants. So there's a problem with how do we control how much liquid is going into, because if you put too much liquid in or too little liquid in, the rocket might explode, the rocket won't work properly. So I think that's a major issue with hybrid rockets that we haven't worked on and we are researching right now.
And then,
Yeah, I mean, adding to Anubhav's point, basically this is called throttling. So, like the amount of fuel, it also depends on the amount of pressure you have in the container. So, you need to have an entire plumbing setup and an entire different pressure vessel. So, it's all the more, difficult to manufacture, and more the number of components. This is one very important engineering thing to learn is the more the number of components, the more the chances of failure are. So we have to be very careful and design, test, prototype for like 2 or 3 years, and then you can finally conclude, okay, this is a proper, reliable working engine. So that is why it takes time.
Then Yash has another question, that how do we obtain the funding for our rocket? So Dhananjay, would you like to answer that?
Okay, so basically we run fundraisers. We are actually a self-funded team. We also have sponsors. Actually, most of it is confidential, but this is what I can say right now.
Then Shantanu asks, what's the flight time of the rockets? So
yeah, the flight time is, you could say it takes around 30 seconds for it to reach 10,000 feet, and then for another 4 minutes it slowly falls down using its parachutes. So around, say, 4.5 minutes, 5 minutes is the total flight time, but it takes 30 seconds to actually reach the height we need to.
To kind of put it into perspective, the work that goes on for like 1 year it just pays off for in those in those couple of minutes or 4 minutes, as Anubhav was saying. For CanSat, I guess it doesn't last more than 2 or 3 minutes, and I guess for the rocket, as he said, it might go till 4 to 5 minutes. But the whole work that you do for a whole year pays off in those. It's either do or die in those 4 minutes. So it's actually exciting to be a part of that journey.
Right. So Abhirami asks, how will the team work when offline, especially with classes all day long? So, all right, we are a part of Creation Labs, and how we work is that we work, we try to complete our work at night, like towards late night, and we get special passes from the college so that we can work inside the lab at night, and that is when we do majority of our work at night after the classes are over.
Any other questions you guys might have?
It's kind of interesting to interact with you guys. So we would like to indulge in more such questions. So shoot freely if you have any questions.
Also, guys, do let us know which domains you're actually interested in from the presentation that we gave today.
Yeah, you can write it down in the chat box. Make sure you join the WhatsApp group that is given there in the message, and you follow us on Instagram as well so that you are updated about the recruitment process. Aditya, yes, we have members in our team who are in the CS department and still are working for the mechanical department. So yes, if you're interested in working for some other department, it totally depends on where you want to work and how well are you able to manage your studies and the work of another department. That is like we do not put a full stop that we do not want someone from electronics to work for mechanical. If you are able to manage it, we won't stop you. Then Shantanu asks, what's the binding agent used in the solid rockets, as it's usually powder?
Yeah, the binding there are like 2 or 3 different binding agents, but I think the most common is a compound called ammonium perchlorate. It's a plastic binder.
Are there any other questions? All right. So yeah, over to you, Pradyumna.
Okay then. Yeah, it was a wonderful session talking to you guys. And as I said, we hope you enjoyed the session and got to learn something from what we had to present to you. So thank you one and all once again. Hope to see you soon.
Thank you.
Thank you everyone for joining.
Thank you, everyone.
Thanks, guys.
And thank you.
Thank you to everybody for joining.
Thank
Thank you.
Shantanu.
Have a good day.